wanted to send out another example from chapter 3.1. This is textbook number 32. You're given the following function and the value for a, which is equal to 1, and then you're asked two questions. One is just to find the derivative at a, and then the second thing is to determine the equation of the derivative. So to determine the equation of the line tangent to the graph. Tangent to the graph at the point, excuse me, I have something on my screen, a, comma, fa. Okay, so part A, what we need to do to find the derivative at a. Excuse me, I had something on my screen here, and it's getting caught on my stylus. All right, so f of a prime is what you were asked to find, which is the same thing as the slope of the tangent line, which we're going to use definition 2. So using definition 2, recall that definition 2 is the limit as h approaches 0 of f of a plus h minus f of a divided by h. So you're given a equals 1, and you have the function f of x equals 1 over x squared. So f of 1, it's not given, you have to compute it. F of 1, when you substitute it into the equation, is just simply equal to 1. So that's your f of a. So now the point that we're looking at is 1, 1, 1. Right? This is a, and this is f of a. So let's substitute in what we know into our equation and solve the limit. So this is the limit as h approaches 0 of f of h plus 1, right, because that's what a is, minus f of a is 1 all over h. Substitute into the equation, and this is 1 over h plus 1 squared minus 1 all over h. And we're going to work on the algebra here. So find a common denominator, and that's equal to 1 minus h plus 1 squared over h plus 1 squared all over h. Continue to work on this algebraically, and we're going to just move that one term down in the denominator, and you're left with this. 1 minus h plus 1 divided by h times h plus 1 squared. So I've got to expand this term, which is the next task at hand. All over h plus 1 squared. So let's see, these two terms cancel out, and I'm left with h squared plus 2h over h times h plus 1 squared. Factor out an h upstairs, and you've got an h plus 2 divided by h plus 1 squared. The h's cancel out. Excuse me, and you're left with Oh, I forgot to, I lost a sign here. I'm so sorry. I'm looking back here what I did, and we lost a sign. I lost a sign. Let me erase that. Why isn't it erasing? There we go. There's a negative sign in front of everything. So this is 1 minus h squared minus 2h. And this is a minus 2h, and this is a minus 1. Just looking at why it didn't look quite right. It's easy to lose a sign, right? Okay, so now those things legitimately cancel out. And I'm left with minus h squared plus 2h. Okay, so factor out a minus h, and I'm left with h plus 1 over, or h plus 2 over h plus 1 squared. Okay, so we're okay there. Substitute in. Now, solve for the limit. Minus h plus 2 over h plus 1 squared. Substitute in 0, and you're left with minus 2 over 1, which equals negative 2. So the slope of the tangent line at the point 1, 1 is negative 2. Next step is to solve for the equation. And recall that the equation formula is y minus f of a equal to the tangent, the slope of the tangent line times x minus a. So this is y minus 1 minus 2x minus 1. Y minus 1 minus 2x plus 2. Y is equal to negative 2x plus 3. And that's your equation, general equation for the derivative.